So that last example took a little bit of time. We found a treehouse, a rope. We dropped the rope down. I showed you how to create the formula for the distance. And then we found the distance of that rope. And then on top of that, I showed you two different ways to find on the ground the smiley face where the rope would touch. Okay? So a little recommendation is just try this problem out, work it out, see if you need your notes, which is totally fine, especially on your first day. But see if you can draw a picture, see if you can remember what the formula is, see if you can derive it if you don't remember what the formula is. But yeah, here it's just saying find the distance between the point Q and a given plane. Now notice, I'm not asking for the smiley face. I'm just saying, hey, find that first distance. How long is the rope? So take a minute, a couple minutes working on that. My answer is below, so when you are ready to resume, you could hit play and take a look at it because I'm about to reveal it. Okay, I won't go over it. This is just a nice little answer key for you to see how I created it. And I want to go on. So instead of a point and a plane, I want to look at a distance between a plane and a plane. Now remember, the only one that really makes sense is if it's parallel planes, because then that distance is constant. Okay? So we're going to take a look at this one where I have two planes. They even draw them for you from the book. And they're looking at the distance between them. Now, imagine if you did not have the book, what you would try and do. Okay? So what I would try and do without having the book, if I was just trying to look for a visual of it, I would immediately draw my version of two planes. Okay? So I'm going to say this is plane 1. I'll say this is plane 2. Okay? You might notice that the n for plane 1 is 3, -1, 2. And the n for plane 2 is 6, -2, 4. Now, they're parallel, which means that their normals should be in the same direction. Are those the same? Yeah, they're the same. Okay? You could reduce it if you wanted to, or blow it up to use the red. Okay? So both of those go in the exact same direction. Both of those are the normal, and I'll probably just use the 3, -1, 2. Okay? Now, the whole idea is I have a plane and a plane, but I want to make it more like a point and a plane. So my whole goal is I'm going to try and find a point here, and I'll call that guy Q. That's on the first plane. Okay? If I move that 6 over, if I hide the y and the z, I got 2, 0, 0. Now notice that's actually the point that they're using from the picture. Okay? And from there, I would also want to get a point here and call it P. Any point will work. Any point at all. So I might go, okay, let's hide the x's and y's. Why not? If I hide the x's and y's, z would be -1. It does not matter which points you use. Okay? So I have that. And now it's more about finding this distance right here, which is coming down the normal. It's my rope from the treehouse. And you can look at this as a plane and a plane, but the way I see it now is I have a red plane and a point Q up above, which happens to be in the other plane. Okay? So then you can just do the distance, as you've done before, is the component of PQ on n, which is the PQ dot n over the magnitude of n. Make sure it's positive, because it's a distance. We can solve it. Okay? So the PQ I don't have yet. I can go get the PQ vector. Let's see, 2 minus that, that's 2, 0, 0 minus a -1 becomes a +1. and you can go with it. And you say, look, I got, let's see, the dot product would get me, oops, I want a different color here. 6 plus 0 plus 2 all over the magnitude of n, which is the square root of 14, which is 8 square roots of 14. Now, if you're noticing this, I'm using n as the 3, negative 1, 2. You could have used 6, negative 2, and 4. You could have totally used that. The reason it doesn't matter is because when you normalize it or unitize it, it would have been just fine right here. So let me show you that 1 second, okay? So if I did use the 6, negative 2, 4, my dot product would have gotten me 12 plus 0 plus 4. Notice everything there was doubled up top. And when I unitize that n, or find the magnitude of it, that would have been the square root of 36, 40, square root of 56. Well, the square root of 56 is is double the square root of 14. So you would have been left with 16 over 2 square roots of 14, which is the same as 8 square roots of 14. So instead of a plane and a plane, focus on making it a plane and a point. So the next problem is a point to a line. And up front, this one's weird. It's weird to orient in space, I think, having one line pierce through the room and having a point above it, below it. The whole thing here is when I say above or below, you can easily say above and below for a plane. You're talking about, am I above the ground or below the ground? But if you have a line, there's so many ways to describe where your point is in reference to that line. Think of it as, it's above and a little bit to the left, or it's below and a little bit to the right. It's to the side. It's to the upper left corner. So with a line and a point, it's a lot harder to even describe the orientation of where is the point from the line. And I think that's why a little bit of this, it's harder to create the formula. Okay? Where I think it was easier to create the formula for the distance from a point to a plane because it's the component scalar, and you can create a geometry trig reference and you can get the formula. But here, a little bit different. So let's take a look. This is what it gives you in the book. It already tells you, here's a line, it's on the ground. There's a point Q off of the line. Right now it's drawn where it's above, but remember I'm splashing it onto a 2D world, so it's either above or below. 3D world, it's all over the place. Okay, you're going to have a point P on the line. And notice, remember, a line is given by a point and a direction. That point is P, and that direction is the vector U. Okay, and it tells you up front, the distance is the magnitude of PQ times sine of theta. Now that makes sense. Just like we did with the point in the plane, this makes sense based off trig, where I have PQ magnitude is this vector, and since I have the angle theta, and I'm looking for this distance here, that's the opposite side, which means I need a reference sine. Here's the issue though. I've never showed you in this chapter yet any way to get sine of theta. I've taught you how to get cosine of theta using the dot product, but I have not taught you how to get the sine of theta. So when you know the cosine of theta and you know that formula in your head, you're like, oh yeah, cosine of theta is u dot v over magnitude of u, magnitude of v. And you use that all the time because you know this one. Well, that's great. You know that one, but it doesn't help you there on this problem. So you need to know something for sine of theta. And here's what I'm going to have you know. Remember this. The cross product, u cross v, equals magnitude of u times magnitude of v times sine of theta. You need to know that guy, because if you don't know that guy, you will never be able to find the distance from a point to a line. Okay? So just like you know the cosine guy, I want you now to know this guy. U cross V is magnitude of U times magnitude of V times sine of theta. Okay? Now, U's and V's. Instead of U's and V's, let's use what we have from this picture. So I could say PQ cross U would equal magnitude of PQ, magnitude of U, sine theta. All I did was basically replace that V with the PQ. Okay? But the distance here, based off trig, tells me it's just PQ times sine of theta. So I don't want that magnitude of U. So I can divide out that magnitude of U, because it's just a number. Okay? So then what's left is I have PQ cross U all over U equals PQ times sine theta, which is what they already told you is the distance. So you can summarize it and say the distance from a point to line equals PQ cross the U all over the magnitude of the U. Very similar to the distance from a point to a plane. Instead of a dot product, it's a cross product. And instead of the normal vector, there's no normal vector for a line. It's the actual direction of the line instead. Okay? So with that in mind, let's try out a problem. Find the distance between the following point and line. So I have a point 1, 2, 3, and the line there. Okay? And that is a 2. I know it looks a little bit short. There's the 2. Okay? And we just learned that the distance, you can always draw the line if you want. Okay? And I like to get the point P on that line. And it's given to you. Remember, it's the front part of it. And I have a point up here, which is my Q, which helps me get my PQ, which is -1, 3, 3. Okay? And I want to find this distance based off that angle. The trig version would be saying that distance is magnitude of PQ sine theta, which from that memorizing, you can equate it to the PQ dot U, or sorry, cross U all over the U, and we can solve it. Okay? So you could say IJK, IJ, IJK, IJ. Okay, so for the PQ vector was -1, 3, 3, -1, 3. And you're going, wait a second, do I have that U vector yet? Do I have this U vector coming out? Yeah, it's the 4, the 5, the 6. 4, 5, 6, 4, 5. So then the PQ cross U part would get me, remember it's a vector, 18 minus 15 is 3. 12 minus a -6 is 18. And -5 minus 12 is -17. So it's that. So I go, the magnitude of 3, 18, -17 all over the magnitude of the 4, 5, 6. Yuck. So calculator out. 3 squared plus 18 squared plus 17 squared is square root of 622 all over 4 squared plus 5 squared plus 6 squared square root of 77. And roughly, that is 2.84 distance. Okay? So, point to plane involves dot product. Point to line involves cross product. Okay? So, here's your homework assignment. 55 is important, 77 is important, and the last set is important, the 93, the 100, and the 104 through 108. And everything else is great practice for you guys. So realize, in 2 days, I really tackled lines and planes and distances between them. This is like a huge geometry unit, trig unit, algebra unit, all of it for calculus in the three-dimensional world. So instead of just dealing with lines on 2D world, we're now looking at everything in a 3D world fashion. So hopefully this helps out. And again, sorry I was gone the last 2 days, and hopefully this stuff goes okay for you guys. Have a great 3-day weekend, and we'll make sure you guys are doing okay with this stuff on Tuesday. You're Calc 3 students though, so it's not going to be you walk in and say, I don't get any of it. It should just be some clarifying questions. Okay, so you're not going, I forgot to do it, I didn't watch it, I don't know, can you start all over again? No. I'll just go over stuff like I normally do and clarify if there's any misconceptions, but I think you guys should be fine with this. I think the notes hopefully helped. See ya!